Welcome back to part 2 of the Python course, which deals with inputs, outputs, numbers, and strings. We are going to start by introducing a function, which is a module of code used to perform a specific task. Sometimes a function even returns a value back to you. So a function, for example, could do a calculation, it could display something on your screen, it could allow you to enter something into the program, and so on. Now, the important thing about every function is that functions have a certain part associated with them called a parameter. So let me just put down the actual text for a function. A function starts off with a specific name, and then inside parentheses we have parameters. So we've got parameter 1, parameter 2, and so on. Those parameters are values that get sent to the function, and the function then works on those parameters only. The important thing about these parameters is that they are only available while Python is running your function. As soon as the function ends, those parameters no longer exist, and that is an important consideration. So we are going to be dealing with two specific functions to start with. The first one is an output, which is the print function. Now, the code for the print function is as follows. We start off with the word print, and then inside parentheses we have strings. So we can put down string 1, string 2, and so on, and we can go on. You can have as many strings as you like. And then another part of the print function are two qualifying parameters. The first one is called SEP, which is a separator, and the next one is called end, which is an end character. Now, how do these actually work? Well, quite frankly, all you need to do to use the print function is to add a string into it. The separator and the end are optional. You don't have to use them each time. But I'm going to do some examples now showing you how they actually work. So if I wanted to display something on the screen, I can say print, and then in inverted commas, I can put down any string information. So I'm going to type hello world. And if I ask Python to run that code, you can see what happens. All it does is display what I have put into inverted commas there, which is the text hello world with an exclamation, and it displays that to the background of the form. So hello world is the program output. The print function enables us to handle the output. Let's do another quick example. If I say print I love Python, and I run that, it displays the words I love Python, no problem. Now let's have a look at what these qualifying parameters actually do. And I'm going to start off with the SEP parameter. Remember that the SEP parameter means separator, and it adds in a separator character into your code. So if I now type print I love Python, just like that. Each string separated by a comma, have a look what happens. We end up with the text I love Python. But now if I add in the separator character, and I can choose any character I like to be the separator. Let's put an underscore in there, and now run that code. We now get the same 3 words, I love Python, but each word or each string is separated by the underscore character. That is the character we chose and we told Python to use to separate each string in the print function. So the separator works very, very simply. I'm going to do another quick example. I will change the separator. Let's put a star in there, for example. And if I run that, we now end up with the same 3 strings, I love Python, but each string, each word is separated using the asterisk. So the separator parameter works very simply. All you need to do is you include it in there to add in a specific character in between each word. Now, why do we actually need that separator? Well, let me give you a nice example. In programming, there's a specific type of data file called a CSV file. CSV stands for comma separated value. And a CSV file is basically a file consisting of a whole lot of data, and each data field is separated by a comma. Now, using the print statement in Python, it's very, very simple to create your own CSV file. If we have a line of code which consists of a whole lot of data, if I say print a whole lot of, sorry, that was a mistake. What I've got are 5 letters, and now I'm going to say use the separator as the comma character. If I run that code now, we end up with a CSV data file. Each value that is being printed, 1, 2, 3, 4, 5, is separated by a comma. So creating a CSV file or a CSV string in Python is quite a trivial exercise using that separator character. All right, now we're going to move on to the end. The end parameter basically allows you to add one specific character at the end of every string. This, again, can be any character you like. So if we do the same thing here, and I wanted to end this off with another comma, as you can see, there's no comma at the end, I can say the following. We've got all that, and I can say I want you to end it off with a comma as well. And if I run that now, the final string becomes a comma, and that is because we've added in the end parameter. So the print statement, just to recap, allows us to output specific data, and it has 2 other functions. The separator parameter allows you to separate each string in the print statement using a specific character or characters. It doesn't have to be one, you can have lots of characters. And the end allows you to add an end character to your specific string as well. The print statement can accept as many strings as you like. So as you can see here, the first example I had 1 string inside the parentheses. Then I moved on to 1 string. Then we had 3 strings. And in the final example, I actually added 5 strings together in the print statement. So the print statement can use as many strings as you like. Now, in Python, there are also specific characters called escape characters, which you need to be familiar with. There is a complete list of escape characters on the website, but I'm going to have a look at some of them now just to show you how you can control the text. The first one I want to look at is the character \n. And \n as a control character means move to a new line. So that is an important one, and we'll have an example with that just now. \r is another control character, which stands for carriage return. The carriage return is basically meaning it moves the cursor part of a line. That's all it does. So \r simply moves to the start of any string that you want to display. The \t allows you to enter a tab stop into your code when you are displaying something, which is quite handy. And then the last two that are also quite important are dealing with different number systems. So if you wanted to display a hexadecimal number, you would use \x and \o is for numbers in octal notation. So let's now have an example showing you how to use some of these. If I say print, and I ask it to print I \n love \n Python, we can see that that is completely one string. We've only entered one string in there. But in between each word, I've got this control character \n, which stands for new line. So if I execute that line of code, instead of printing out I love Python all on one line, like we had there, we now have the three words I love Python on separate lines, because the \n is telling Python to move to a new line before it prints the next characters. So it prints I, new line, love, new line, Python. If we wanted to, let's have another quick example. If I type in print I, let's go for \t love \t Python. Now the \t puts a tab stop in between, and a tab stop is equivalent to 4 spaces. So if I print that out, we can see now we've got large spaces in between each word. Right, so these control characters simply allow you to format your code nicely. That's all it does. It's a very nice way of handling code format. Right, so that's it for the print function. It's quite simple to use, and all it does is it takes either one or a number of strings and allows you to display them on the form or on the screen. You have a separator character which you can choose, and you have an end character which you also have control over and can choose. We're now going to move on to the next function, which is called input. And the input function takes in a specific prompt. A prompt is a string, and that prompt is displayed for you. The input function then halts program execution. It does not carry on executing your program until the user presses the enter key on the keyboard. This allows you to enter something into Python, so into the program that you are writing. Whatever you enter goes into something called a variable. Now, you're all familiar with variables already from mathematics. X is a variable, Y is a variable. In Python, you can create a variable out of any name you like, as long as it's not one of the keywords in Python. So you couldn't call a variable input or print, for example, because those names are taken already by functions. But you can create any other variable. So, for example, if I type the word S equals, this is a string. What I've done is I've created a variable called S. And the data that's contained in that variable is this one string consisting of the words, this is a string. So that string will be moved into the variable called S. So that is what a variable is. You don't need to create string variables. You can have numeric variables as well. A equals 10, exactly the same. That is a numeric variable. So let's have a look now how we can use the input to enter data into your program. So if I type the word input and I say enter a number, and I run that code, what's going to happen is a prompt appears on your screen which says, please enter a number. That is exactly what you typed in as the string there. And it now waits for you to enter a specific number, and you can enter whatever you like. Right? So as you can see, I entered the number 2654.85, and that is what goes into Python. Now, this is very important. You'll notice that the number that I entered was just a number. However, when Python displays what I entered, it displays it as a string. You can see the single quotation marks before and after the number. Very, very important is that all inputs in Python are strings. If you want to enter a number, we have to convert it into a number after it's been entered. So everything that gets entered into Python is regarded as a string input. Let's now do some examples on how we can use this. I'm going to create a variable, and I'm going to call this variable name. So I'm going to type name equals input, and I'm going to say enter your name. And once that code runs, I'm going to say print. I'm going to print the word hello, comma, and then I'm going to add in the variable we created, which is name. So let's have a look what's going to happen here. When we run this little bit of code, enter your name as the prompt is going to be displayed on the screen. And Python is going to then allow you to enter, hopefully, your name. Obviously, it doesn't know what your name is, so you can actually enter anything you like. Whatever you enter will then be moved into the variable name. The next line of code, excuse me, the next line of code uses the print statement, and we've got two strings in that print statement. The first string is the word hello, and the second string is now your name. So let's run that code and see what happens. The first thing it does, it says enter your name, and I can enter whatever name I like. So I can say Billy Bob. And when I press the enter key on the keyboard, Python then accepts what I have taken in, and it displays hello and the name I entered, which is Billy Bob. So we've got the string hello Billy Bob displayed on your screen. So all that takes place in that line of code. So in this little program, two-line program, we've got an input and we've got a program output. Now, almost every program that you write will consist of both an input and an output. Somehow your programs need to have you controlling them, so you need to input some type of data. And a program that doesn't display anything or have an output is also reasonably useless because you don't know what's happening. So most of your programs are going to contain both inputs and outputs. Right, let's have a look at some more examples. So I'm going to type the word input, your first name. Now, remember we're using the input, so that input, whatever you type, needs to be put into a variable. So I'm going to create a variable which I'm calling first name. I'm going to create another variable called last name, and I'm going to use the function input, and I'm going to say enter your surname. Once that is done, I'm now going to create a new string which I'm going to call greeting. I'm going to say greeting is equal to the word hello. Let's just see what happens when I do this. Then I'm going to add in first name and finally the variable last name. And once that is done, I'm then going to tell it to print out the variable I've created, which is greeting. Now let's have a look at what happens if I try and run this code. It comes up first of all and asks me to enter my first name. It then asks me for my last name. Then it displays something a little bit odd. When I say print greeting, it displays each string separated by commas. Now, this is not what we want. I want to display one string which would say hello and then the two strings I entered, which is Bill Smith. So the reason this didn't work is because we are using commas here to create our string. I'm trying to create a string called greeting, and I've separated each of the other strings using a comma. So basically, what Python has created is a little CSV file. We've got three strings, hello, Bill Smith, and each variable is separated by a comma, which is comma separated variable. So to be able to do this properly, I need to introduce something to you which is called concatenation. Now, concatenation, it's a beautiful word, and in programming circles, concatenation means adding or joining together. It allows us to take data and add it into one structure. To concatenate, we use the plus symbol in Python. So the symbol to concatenate is simply a plus sign. So what I'm going to do now is to take this code that I previously did, and I'm now going to modify it. So instead of saying hello, comma, first name, comma, last name, I'm going to say hello plus first name plus last name. So by using these plus symbols, we are concatenating the data. I'm saying I want you to take the word hello, add in the first name, and add in the last name, and put it all into one variable called greeting. And then I want you to display that greeting to the screen. So if I run the code now, it should work, but we've still got a few problems which we'll sort out. So let's have a look. If I run it, it says, what is your first name? I'll put Bill Smith, and it comes up and says, hello, Bill Smith. But you'll notice now that concatenating does not add in any spaces. So we need to manually put spaces in when we are using the concatenate plus sign. So again, if I want to run this line of code, I would have to put a space after the word hello. And then we need a space in between first name and last name. So to do that, I would need to open my inverted commas, add a space in there, and add another plus sign. So the complete string is now going to be hello, space, first name, space, last name. So again, if I run that code, it will ask me for my first name, it'll ask me for my last name, and then it displays the string exactly like we want. Hello, Bill as the first name, Smith as the last name, and each word has a space in between. Because this is a string, it's quite easy to add in that space. But if you didn't have a string, you would then need to add in another space, just like we're done at that point there. So that line of code will end up with exactly the same result as we had previously by putting the space into the string after the word hello. And we have the spaces put in the correct places in that string. All right, so that's concatenation. Very, very useful. We will be using concatenation not only with strings, but with all other data types as well in Python. So please be familiar with them. You need to know how to concatenate data. It's quite simple. All you're doing is using the plus sign, and whatever you've got on both sides of the plus sign will be then joined together. All right, at this point, last week I mentioned a document in Python called pep8. And the pep8 document details all the rules that Python requires when you write code. And part of that pep8 document tells you how to create names for your variables. And we are going to use that document. So you'll notice that when I create a variable, for example, first name, that variable starts off with lowercase letter, and then the next word in the variable starts with a capital. So we've got a capital N for name. Last name is exactly the same, lowercase, and then the word name starts with a capital N. So that's how we create variables in Python. The word greeting is also a variable, but because it only consists of one word, it's all lowercase letters. The pep8 document is quite important, so you need to read it, because basically what it says is the following. If you create variables, which is var1, var1, and var1. As far as Python is concerned, those are three completely separate variables because Python is case sensitive. This means that it takes uppercase and lowercase letters into account when you're creating anything. So please be aware of that. If you make a spelling mistake, in other words, if you create a variable in your program and then later on you put a capital letter in by mistake, Python immediately thinks you're creating another variable. And it is a big cause of concern for students starting out with programming. It's very difficult to find because now you suddenly have a new variable which looks almost identical to the previous variable you've created. So please stick to the naming convention that all your variables are lowercase unless they consist of more than one word, which means that any subsequent word in your variable name will start with an uppercase letter. The next thing to realize is that when you're creating a constant, we'll deal with this later on again, but when you are dealing with a constant in Python, your constant is all uppercase letters. So if you're creating a value for pi, you cannot create pi like that. You cannot create it like that. Pi created as a capital P and a capital R because it is a constant. So please bear that in mind. Right, so we've dealt with inputs and outputs. Inputs are the input function, outputs use the print function. Now we're going to move on to different numbers in Python. There are 4 types of numbers that Python can understand. We've got integers, we've got floats, we have got longs, and finally we'll deal with complex numbers. So let's start off having a look at an integer. An integer, as you know already, is a whole number. And to create an integer in Python, it is very simple. We simply use a variable name, call it whatever you like, and then we give it a name, a value. So we can create a variable consisting of -15. We can create a variable of 32. So those are 2 variables which are now integer variables. The first one has a whole number in it, -15, and the second one has another whole number in it, which is 32. In Python, we can create multiple variables at the same time. So we can say CDE is equal to 42, 65, and 9. And Python will handle that perfectly well. This is actually very nice because it allows us to create multiple variables very, very easily. Just to make sure that those variables were created properly, I want to print out A, B, C, D, and E. And we can see when we run that, Python displays the 5 integer value variables that we created. A is -15, B is 32, we've then got a 42, a 65, and a 9. So there is our data. So integer variables are very, very simple. We can also create variables, integer variables, based on variables that have been created previously. So if I wanted to create a variable f, which consists of 2 times b, I can do that without a problem. And I can say printf, and we end up with the value 64, because b is equal to 32 and f is now equal to 64. So variables are used exactly the same way as they were done in mathematics. You can create them, you can give them whatever name you like. You don't need to stick to just A, B, C. You could have called it variable 1. equals 42, print variable 1, and we end up with the value 42. So naming your variables, you can use anything you like to name them, and it will work just fine. So integer values are whole numbers. The next type of value we want to look at is something known as a float. Now, a float is any numeric value that has decimal places. We can also create a float in Python which doesn't have any decimal places data, but we have to use the full stop. So all floats use the notation A dot B. So the dot notation allows you to enter floating point data. So if I say W equals 14, that will create an integer. But if I want to create a float, I would have to say W equals 14.0. We now have float data in there. And we'll see the difference. If I say print W, it now tells me that W is equal to 14.0. It shows me that that value is a float. So even though the integer value 14 and the float 14.0 numerically is the same thing, in Python, it accepts those two values as being different because they are different data types. The one is an integer and the other is a float. We can also create a float variable simply by typing 2. You don't need to include the last 0. So that creates a variable W, which consists of floating point data equal to the numeric value 2.0. We can say multiple values as well. X comma Y equals 3.21 and 89.62. And that will work just the same. We can say Z is equal to -1 times X, and that will work just the same as well. So if I print out the data we have now, if I print out X, Y, and Z, we can see what we have. We've got 3.21, which is X. We've got 89.62, which is Y, and Z is equal to -3.21, which is -X. So floating point data is very, very simple. Now at this point, I want to move on and just talk about constants. As I said previously, when we create a constant has to be all capitals. So if I wanted to use the word pi in my code as a value, I could create it in pi is equal to 3,1415927. So there's the value for pi. We know it's a constant, and because it's all capitals and it's a constant, we know that that value should not be changed. We all know what pi is, and pi is a constant. It means that it doesn't get changed anyway. There are lots and lots of other constants we can have. For example, we can have the speed of light is a constant. The speed of light is equal to 299.79 times 10 to the 6 meters per second. Now, why I'm putting this in here is because I want to show you the notation that we use in Python to enter values times 10 to the whatever it is, which is called an exponent. So to do that, we either use a capital E or a lowercase e, and then the exponent. So we've created a variable now for the speed of light equal to 299.79 times 10 to the 6. And that's what Python will accept. Let's just have a look what those values look like. If I type speed of light equals, and then I type the constant speed of light, and as usual we need to add in the units. If I run that now, Python comes back and says, right, the speed of light is equal to, and have a look here, it takes the e to the 6 and works out what the actual number is when it gets displayed. So we've got 299,790,000 meters per second. All right, so all constants get a capital. So the variable name is all capitals. And in Python, all constants are floating point values. Right, the next data type we want to look at is data type long. And data type long is a nice little data type which allows us to work with numbers to different bases. As you know, our number system traditionally is to the base 10. So all these numbers we dealt with here is all base 10. But in electronics, we often work in hexadecimal numbers or in binary numbers. Python allows us to work in those different bases by using data type long. So if we wanted to work with hexadecimal numbers, we use a 0x as a qualifier. If we wanted to work in binary, we use a 0 and a b as a qualifier. And for octal, we use a 0 and a lowercase o as the qualifier. So for example, if I wanted to create a string of binary data, I can say that tx is equal to 0b, and then I can give it the binary data like that. If I then print that string out, Python comes back and says, right, well, that string is equal to, and this is interesting, it's equal to 171. Python automatically does the conversion for you from the binary string which we had, the binary data, which is 10101011, and converts it into base 10, which is decimal, and displays the result, which is 171. The same thing happen if we use hexadecimal data. If I say hex is equal to 0x, and then I'll make some data up, I'll go ffef, and I ask it to print out this variable hexa, we can see now it converts the ffef into 65,519, which is the decimal equivalent of that hexadecimal number. So hexadecimal, binary, and octal can all be represented using data type long in Python. The final data type deals with complex numbers. Complex numbers, as you all know, is a mathematical notation which we need in electronic engineering and other forms of mathematics as well. They use it quite often. A complex number consists of two parts, a real part and an imaginary part. And there are two ways of creating complex numbers in Python. The first method is to use the plus symbol and J notation. So if I type CPLX1 for complex 1 is equal to 2 plus 3J, I am now telling Python to create a complex number the real part being 2 and the imaginary part being 3. The other method of creating a complex number is to use a function called complex. In Python, we have a built-in function, and then inside parentheses, we again specify the real part and the imaginary part of a number. So if we wanted to create a number with the real part of 2.5 and the complex part of minus 1.65, we would use that string. We use the function called complex, and then the real part goes inside parentheses, the imaginary part inside parentheses, and the two numbers are separated using a comma. Just to show you what Python does when we print them out. I'm going to print them on a new line. We can see that we have the two complex numbers. Now you'll notice that when Python displays a complex number, it displays the number inside parentheses. This is a specific type of data which we'll speak about later on. It's called a tuple. We haven't done it yet, and we'll deal with tuples in a lot more detail later. So the first complex number will be 2 plus 3j, and the second complex number is 2.5 minus 1.65j. You'll notice that in Python, it accepts j as the imaginary indicator. It does not use I, which is actually quite nice for electronic engineering because I is specifically current. The last thing to know about complex numbers is that complex numbers are always accepted as floating point values in Python. So Python will automatically think of it as a floating point. We can do arithmetic on complex numbers as well. If I ask it to print out CPLX1 plus CPLX2, Python will handle that without any problem, and it will give us the result. Complex number 1 plus complex number 2 is equal to 4.5 plus 1,35j. So complex numbers are handled very, very easily in Python, and this is a huge bonus for us as electronic engineers. All right, so that's it for our number system. What we're going to look at now are the different ways in which Python can handle numbers. And the first thing I want to talk about is Boolean values. In Python, all Boolean values are accepted. Now, as the class, you should all know what a Boolean value is, or a Boolean operator, because you dealt with it in digital systems. In digital systems, as well as in maths previously at school level, you had a whole lot of Boolean operators. Less than, let's just put them down. We've got less than, greater than, equals. We've got less than and equals. We've got greater than equals. And finally, we've got not equals. In Python, these are written out using specific notation. Less than is obviously just less than. Greater than uses greater than. If we want to check whether two values are equal to each other, we use a double equal sign. Less than equals is exactly the same. Greater than and equals is the same. But if we want to check that two values are not equal to each other, in Python, the not equals is an exclamation mark and an equal sign next to each other. Now, what is the important thing about using these Boolean operators? The biggest thing you need to know is that any Boolean operator will result in a value which is either true or false. A Boolean expression can never evaluate to anything else. It is either going to be true or it is going to be false. So let's have a look at some examples. If I type A equals 10 and B equals 7, and then I ask Python to print if A is less than B, it's going to come back and tell me false, because A is not less than B. If I ask it to check whether A is greater than or equal to B, Python comes back and says, right, well, that's true, because A is 10, B is 7, so A is greater or equal to B. If I say print A not equal to B, again, Python comes back and tells me that that is true, because A is not equal to B. A is 10 and B is 7. Let's do another little example. If I say A is equal to 2 and B is equal to 2.0, we'll know that numerically speaking, A and B is the same. If I now say print A equal to B, it comes back and says true, which it is, because numerically speaking, they have the same numeric value. The first one is 2 and the second one is 2. So even though they are different data types, that is an integer and B is a float, this comparison will still give you the correct result, and that is important. All right, so that is for Boolean operators, and we are going to be using Boolean operators all the time in Python when we need to do repetitive code or get Python to actually make decisions based on certain things. We're now going to move over to arithmetic operators. An arithmetic operator are things that you learned at school. I think at school you had BODMAS or BOMDAS or something like that, where you had your order of precedence of all these operators. And in Python, it's no different. So I'm going to have a look at some of these operators. The first one are your standard parentheses. Parentheses are always calculated first. Whatever calculation is inside your parentheses is always handled first. The second order is a double asterisk sign or double multiplication. And this stands for exponentiation. What is that? That's raising a power. So when you've got A to the power of B, it is written like that. So exponentiation will come next. The third in the order of precedence is your minus sign on its own, which is called negation. Negation simply changes a value from a positive to a negative or from a negative back to a positive. So that is your negation operator. Next, we have the standard multiplication, division, and then we've got two special characters, which is a percent sign and a double forward slash. Your asterisk, as I've said, is multiplication. Your forward slash is floating point division. The percent sign is something known as a modulo or a modulus calculation, and I'll give you an example just now of what it does. And finally, 2 forward slashes together is known as floor division. Now, let's have a look. Modulo is the remainder from a division. So the modulo function will only turn the remainder part of a floating point division. Floor division returns the integer part of a division only. And then finally, right at the bottom of this whole order is your standard plus and minus. So that's your plus and your minus symbols. So those are the orders in which Python will evaluate any calculation. So to give you some examples, if we type out print 3 plus 4 times 5, Python will evaluate that, but it will evaluate 4 times 5 first to get 20 and then add 3 to it. So the answer will be 23. If it did it the other way around, it would take 3 plus 4, which is 7, multiplied by 5, which is 35, and get the wrong answer. So Python will automatically use the general mathematical order of precedence to give you correct results. If we wanted to take 2 to the power of 3, Python will then come back and say, right, 2 to the power of 3 is equal to 8, which is correct. There is one thing that you need to know about exponentiation, and that is the fact that for exponentiation, Python will always have or return a result of a float, and it always starts on the right hand side. Now when I say that, let's do an example to show you what I mean. If I want to calculate 2 to the power of 2 to the power of 3, Python is first going to calculate that 2 to the power of 3 and then take that result 2 to the power of whatever that result is. If we started with this calculation, we are going to get the wrong result, because 2 to the power of 2 will be 4, and then 4 to the power of 3 is 64, which is the wrong answer, because 2 to the power of 2 to the power of 3 actually should produce 256. Remember, 2 to the power of 3 is 8, and 2 to the power of 8 is 256. So for exponentiation only, Python starts off on the right-hand side and works from the right to the left. For exponentiation, floating point numbers are handled as well. So if I wanted to calculate the square root, for example, of 2, I can say a comma b is equal to 2 comma 0.5, and then I can ask Python to print out the result of a to the power of b, and it will come back and say 2 to the power of a half, which is the square root, is 1,4142, and so on. So floating point values are handled quite well in Python when we deal with exponentiation. Operator I want to talk about is modulo. Now, as I said, modulo returns the remainder from a long division. So if I ask Python to print out 9% 4, it's going to come back and tell me that that is 1, because 9 divided by 4 is equal to 2 remainder 1. So it returns the remainder part only. Again, when we're dealing with the modulo, floating point arithmetic also takes place. So if I ask it to print out 9 modulo 3.5, well, how many times does 3.5 go into 9? It goes in 2 remainder 2. But this time you'll notice that because we are using floating point divisor, the answer is in floating point notation. Right, so we've now got a floating point answer. So that is what the modulo function does. It returns the remainder from a long division. Now, floor division is the next thing we need to talk about. And floor division, let me just get the spelling right. Floor division returns the integer part from a division only. So again, if I ask it to print out 9 floor division 4, it's going to come back and tell me that the answer is 2, because 9 divided by 4 is 2 remainder 1. There it is there. So there's the remainder part, and there is the dividend. So floor division will always give you the integer part. Again, floating point arithmetic rules also apply. So if I ask it to print out 9 floor division 2.0, it's going to come back and give me an answer in floating point notation, because 9 floor division 2 is equal to 4 remainder 1. So the integer part is 4.0. So that's it for floor division. The others are quite specific. Multiplication, division, addition, and subtraction you know how to use already, so you use them exactly as you've learned. The last thing I want to talk about in the number system is that in Python we use specific shortcut operators. Now this is taken from C, where these shortcut operators were introduced to allow you to type in less code. So I just want to indicate to you how they actually work. In maths, you can quite easily say x equals x plus 1, and that's not a problem. And you can actually do that in Python, and Python will understand what you're talking about. But in Python, there's also a shortcut you can use by typing x plus equals 1. So how does this work? Well, basically in Python, if you take any variable equals variable operation value, which is what we did here. We had a variable equals the variable, a mathematical operation, and then a numeric value. We can then combine that into this shortcut notation by saying variable operation equals, and then the value. So variable operation equals value works perfectly. Please excuse my dog from howling. There seemed to be somebody at the gate. Right, just to give you some more examples. If I type a equals a plus 3 times b, where a and b are variables, in shortcut notation, in Python we can say a plus equals 3 times b. So that part, the a equals a plus 3, has been combined into the shortcut notation a plus equals 3. This doesn't only work with plus signs, you can use it for multiplication, for division, even for powers. So if we had, let's say, x equals x to the power of 3, we can type that in shortcut notation by saying x power equals 3, and that will work exactly the same way. So the shortcut notation, you need to be familiar with it, because a lot of the examples that I have posted and a lot of the examples that you will see when you do your research online on the internet use this shortcut notation. So please get familiar with it so that you can see exactly how it works. Right, to finish up today, I want to now look at conversions. Earlier, I told you that when we use the input function in Python, it always allows you to enter a string. So what happens now when you actually want to enter numeric data? Let's say you want to create a program which asks you to enter your age. It's going to be pointless if you have to enter a string. Python's not going to be able to handle that very well. So there are conversions that we use, and the two main conversions that we are going to be using is the int and the float. So if we want you to write a program to allow you to enter your age, we could say something like this: age is equal to input, enter your age. Now, if we ran it just like that, when you enter something, it is going to be a string. So what we now need to do is to convert that string into a numeric value. Let's run this program without entering the conversion. So if I say print age and I run it, it's going to come up and say, please enter your age. I'll enter a value, and it comes back and says, right, that is your age. But strictly speaking, your age is an integer. So we need to now convert it to an integer by typing int and placing that whole input string into that conversion. So if I ran this now and entered a value, it comes back and says, right, your age is 42. Again, we can do the same thing for a float. If you are entering numeric data, let's say you want the length of something. If I say the length is equal to input, enter the length. I'm going to say print twice the length equals, and then I'm going to add in 2 times the length. When I run that, it's going to ask me to enter a length. I'm going to say 5.69, and then it comes back and says twice the length is equal to 5.69, 5.69. Now that makes absolutely no sense. And the reason it doesn't make sense is because this is a string. So by saying print out twice the length, what Python is doing is just printing out the length 2 times. And there it is, 5.69 the first time and 5.69 as the second time. So let's have a look now if I convert this to a float. We now have the float conversion. It's asking me to enter the length. And if I run this now and say 5.69, we now end up with twice the length equals 11.38, which is correct because now length is not a string, it is a float. So that calculation is performed 2 times that float number gives you the correct answer. So people, when you are entering anything, you need to be specific as to the data type that you are wanting the person to enter. If you're entering strings, you don't have to do anything. If you are entering a whole number, you have to use int. And if you are entering a floating point number, you need to use float. All right, to end off today, I'm going to do a quick example. I'm going to ask you to write a simple program which calculates the volume of a box, given the length, the width, and the height. Okay, so the volume of a box, basically what you need is the length, the width, and the height of a box, and you need to now calculate and display that. Let's assume that the box is in centimeters. All those values will be in centimeters. So the first thing we need to do is to write 3 input statements. We need to create variables for the length. Because we're dealing with numeric values and we don't know what the person's entering, we're going to use a float. So we've got float, input, enter the length. So there's the first line. Now we need to do exactly the same for the width and the height. Width is equal to float, input, enter the width, and we do the last for height is equal to float, input, enter the height. So there are our 3 inputs. First one for length, second one for width, last one for height, and all of them will allow you to enter floating point values. The next thing we need to do is to calculate the volume of this box. So I'm going to create another variable which I've called volume, and the volume is simply the length times the width times the height. So that will calculate volume. The last thing we need to do is to display the result. So we can say print volume, and that will actually work. So let's run it and see if it works. When I run it, it asks me for the length. I can put the length of the box in there, the width and the height, and it will come back and tell me that the volume of that box is 70.21. That brings us to the end of part 2. Thank you for watching. If you found it useful, please click on the subscribe button below.